that dark enough? Can everyone see? All right, cool. Welcome to Metaprogramming. My name is Max. I'm a fourth-year computer science major in the engineering school, and I became a big metaprogramming fan over the past couple of years from a combination of personal projects and work experience. And so what I want to do with this class is share my love of metaprogramming with you. So I'm hoping that not only will you learn some techniques and how to become a Python ninja, but also just kind of a general appreciation for metaprogramming in general. Yeah, I think what we'll learn is very useful, especially it's come up in interviews. I taught this class a couple semesters ago, and several people came up to me afterwards saying that they had been asked about something that we talked about in metaprogramming in an interview. So it can be useful for that. It's also just useful in general whenever you're trying to do something powerful. You know, the more techniques you have to layer on abstraction, the more powerful you can, the more expressive power you have. So it's useful just in general kind of tasks. So I should probably say what metaprogramming is so that you can know if you actually want to learn more about it. It's exactly what it sounds like. It's code that manipulates code. So an example of a metaprogram might be something that reads code. If you write a program that reads in code, then that's metaprogramming. And so I bet you can already think of several examples of metaprogram, but metaprogramming also can modify code. So you might be able to think of an example that does that, although that one's a little harder. And metaprogram outputs code. So you can probably think of an example of that too. Can anyone think of an example? Can anyone think of an example of a metaprogram that they've used or seen? You can go for the low-hanging fruit. Yeah.
Compilers.
A compiler. Yeah, a compiler. A compiler is kind of a classic example of a metaprogram because it reads the code that you wrote, and then it outputs that code, but in a different language, usually a lower language, closer to the hardware. Can anyone think of more examples, ones that didn't show up on screen briefly?
Quine.
A quine? A quine is definitely a metaprogram. Yeah, a quine, if you haven't taken 2150, is a program that outputs itself. So if you run the program, you take the output, copy and paste it, and run it again. You can take the output, copy and paste it, and run it again. You can do that over and over and over again because the program outputs itself. So yeah, quine is a metaprogram. Other examples?
Does import count?
This?
Import, yeah.
Import definitely has some meta properties, but I wouldn't say it by itself is a metaprogram. Well, actually, it depends on the language. So in Python, when you import something, what are you doing? Does anybody know?
It's like functionally equivalent to copying and pasting some code.
Yeah, importing in Python is taking some other Python file and executing it, and taking all of its stuff. So if you import math, what you're really doing is you're executing Python's math library, and then you have all of that code that just got executed. So import, yeah, I guess import is kind of meta, yeah. Any other examples you guys have?
Like pre-processing.
Pre-processing, yep. Let's see, so I've got compilers here, but has anyone heard of a compiler? So that's something we'll get into eventually. If a compiler is a metaprogram, then you better bet that a compiler is a metaprogram. So we'll go several levels deep on that. Servers, whenever you hit a web page, what are you really doing? You're downloading some code that your browser knows how to execute, right? But if you're downloading code, then something had to serve you that code. So I would argue that servers are metaprograms because they serve up code. HTML, not really code, I guess, but JavaScript is certainly code. And if a server sends you any JavaScript, then that server is kind of acting as a metaprogram. Server builders. So who here has used Django? Okay, maybe a little less than half. Okay. Django is right? Is that the word? Right? It has a lot of metaprogramming in it. because if a server is a metaprogram, then this server framework is really very meta. It builds servers for you. So it's levels to go there. And metaprogramming is very dry. The goal is to always be as succinct and concise as possible. So, if there's something that you find yourself repeating in code, like maybe you keep writing the same exact print statement over and over again or something, then the principle of dry says that you should find some other way to do that, because every time you repeat yourself, you're opening yourself up to copy and paste errors or all sorts of things. And it's just generally better to have a more concise code base. So metaprogramming is very helpful for that. Welcome. Let's see. Yeah. I like this picture here. It's kind of meta. Doesn't have anything to do with code, but it's kind of cool. Let's see. I've got the schedule here. We're going to do object-oriented Python today and the week after Martin Luther King Day, because there's no class next Monday, so don't show up. But then the week after that, we'll continue doing object-oriented Python. Then we're going to do first-class functions, closures and decorators, meta-class, reflection, compile-time computation, code generation, language metaprogramming, homoiconicity, applications, and then there will be a final. Note the quotes around final. Yeah. So who? Let's see. First off, I want to get a sense of what the class is like. So raise your hand if you're a first year. Okay, handful of first years. Raise your hand if you're a second year. Okay, third year. Okay, fourth year. Awesome. So pretty good mix. Let's see. Raise your hand if you're actually enrolled in the class. Okay, because I know I have some people here who just came to heckle me, I think. But it looks like most people are actually enrolled in the class, so that's awesome. There was a hard prerequisite enforced by SIS that said that you had to take 1110 and 2110, but I took that off because I wanted to let people take it even if they haven't taken those classes. I know a lot of people come out of high school with some experience in object-oriented programming, even if they haven't taken 2110. So if you have people who are waiting, or trying to get in, but they didn't have the prereqs, if they think they know object-oriented Python, then tell them they can just go ahead and enroll. Let's see. I think that's all I got. So we'll be doing lecture. Right now I have planned every single possible lecture, but I haven't written every single possible lecture. So it's quite possible that I'll get lazy or busy and some lectures will just be canceled because I don't have time to write them. And I'm a fourth year, and so priority is having fun this semester. So. Lectures will be pretty straightforward. I like slides, so I'll have slides. But I'll start each lecture by going over the homework for last lecture. That means that there's no late policy. Homeworks will be due the week after the lecture on them, and then after that, I'm not going to accept them. And that's just because I want to go over it in the next class. So, let's see. The homework, at first there will be homework every week, but then it'll kind of taper off because we'll get to some, things that are so meta that you can't program them. So, but most of the homeworks will be, or all of the homeworks will be Python puzzles. So there will be some sort of objective, something that you might not thought of was possible, or some sort of, there will be a bomb homework if you've taken CompArc. But they'll take some sort of metaprogramming to solve. And the reason I have homework is just because metaprogramming is it can feel very abstract, it can feel very hard to understand. And I think the best way to understand it is to just do it. So I've tried to make these homeworks kind of set up a scenario where the only thing you really have to focus on is what metaprogramming to do to get your goal. So there shouldn't be too much other fluff. I hope that the homeworks will be pretty quick. That's one thing I changed this time around is I've added testers or runners, so that you can just hit run and test your code. Hopefully those will work, but bear with me because I wrote them kind of quickly over winter break. So there might be some bugs, but we'll get through it. Cheating policy, I don't really care. Like, I would be lying if I said I was going to check for cheating. Like, I'm not. And in fact, I would love to see collaboration. So if you have people you want to work with, go ahead and just work with them. But I do ask that everybody submits their own code. But it's not like 2150 where if you've looked at the other person's computer screen, then you failed. Like, do whatever. But do submit your own code. And I hope that you take the assignment seriously because I did put time into them and I think they're the best way to learn the material. If you use anything cited, yeah. Okay. So I want to jump right in and start going over object-oriented Python. And the reason I want to do that is because the prereqs were 1110 and 2110. 1110 you learn Python, but you don't learn object-oriented Python. Am I correct? You still don't write a class in Python? Okay. And then you take 2110 where you learn Java, where all you write is classes, right? Still, I'm assuming you've written methods in 2110. Correct me if I'm wrong, it's been a while. Okay. But you haven't actually written classes in Python. So Python has just about everything that Java has, but it's a little different. And so I want to start by going over classes in Python specifically. Raise your hand if you have written a class in Python. Okay, so a good number of people actually. So yeah, this might be a little slow to start, but trust me, like we'll get into the heavy stuff real quick. But I just want to make sure that we're starting on the same page. So we're going to go over classes in Python today, and then next time we're going to go over inheritance in Python. And I guarantee you, if you think you know inheritance, you don't know it in Python. So hopefully it won't be too slow. But I do want to make sure everybody is on the same page. So we're going to go over classes, constructors, fields, methods, init versus new, duck typing, ubiquity, homogeneity, and then we're going to maybe do some group coding if there's time. We'll see. So the way I like to do slides is I like to kind of mock live coding because I think live coding is awesome. The problem is live coding is really hard. If you mess one thing up, then you're screwed. So what I do is I'm going to have code up on the screen and it's animated as if I were coding it. So, oh, look, I just wrote that. So that's how you make a class in Python. You just use the class keyword and then you name your class. One thing to note here is that we're going to be doing Python 3 in here. Python 2 is officially dead. So Python 3, obviously. Yeah, you use the class name and the class keyword, and then to define, the spacing is not right. Well, okay, this is the woes of doing this on a new computer. Bear with me, that's supposed to be more indented. I think it kind of messed up the ellipses here. In Python, obviously, indentation is very important, so note that def should be indented one more time. And so the idea is that you, to write your methods, you just define functions that are indented inside of that class body. It's pretty similar to Java. One major difference here is that you'll note that this function took in a parameter self here. Does anybody know what self is? Anybody explain what self is? Mm-hmm.
Pointer to the object.
A pointer to the object, yeah. So, and with a class, what you're writing is basically a factory for making objects, building a template. A class is a template, and then you can create instances of that template, and those are objects. And so self is just any one of those objects. And it's basically the same as this from Java. So if you know Java, self is this. We leave a blank space to make the shell happy. And so now this is how we make an object in Python. There's no new keyword. So unlike Java, you don't have to say new. You just take the name of the class, throw some parentheses on it, and boom, we have an object. Any questions about that? Okay. So if we call the high method that we wrote up here, call it with a dot, you throw some parentheses on it, but what's the weird thing here? Mm-hmm.
You don't explicitly pass the self.
Yep. Yeah, the weird thing is here, we wrote this method to take in self, but we didn't pass it in here. This is a method that takes in one parameter, right? So what's weird about object-orientedism in Python is that you write these methods with this parameter, but then Python passes the parameter in for you. So by saying thing.method and calling that method, Python knows, oh, we'll just go ahead and pass f in as self. But interestingly, you could do actually. Can anyone see if I write over here, like over there? You guys can see this board just a little bit. Okay. Interestingly, what you can do is you can say foo dot high and then pass in f. Those are equivalent. So this is one of those weird things about object-oriented in Python. Basically, though, for the time being, we can just forget about this self parameter. Just don't forget to put it there, because Python will complain if you don't include self. So, questions about this? Let's get one question about it.
Should you put in more parameters like other than self, like a self and a number?
Mm-hmm. What happens?
Right.
Up here or that?
Yeah, up there.
Mm-hmm.
Like with self and like in.
Mm-hmm. Yeah, so if you want to specify more parameters, you just tack them on after self. And then when you call the function, you put those parameters in here, but you still don't need self. Yeah, good question.
You might not know this, but does Python like do this kind of code transformation from f.high to foo.high f, or does it kind of do it without ever altering the code, just under the covers?
It doesn't alter the code, it doesn't under the covers. It has to do with how object lookup works. So it turns out the dot, like every little dot you see is quite a complex operation. And in Python, there's some under the hood stuff that that figures out if you're trying to make a static reference or a non-static reference, and then it returns the function that you meant to call. So here, this is a non-static reference, because we're calling on the object itself. That's a static reference because we're accessing it on the class itself. So there's some under the hood stuff that figures that out. But it's not doing code transformation. It has to do with the object lookup. Yeah. Other questions about this? Okay. So when we call the high method, what we get is a foo object at this memory address. So what did the high method do? The high method printed out self. So apparently self, like I said, is just the object. It's any one object of this template that we've written. Now if we just print f, we get the exact same thing. So that's kind of a proof there. F is self, and these two things are equivalent. Questions about that? Okay. So just like in Java, there are constructors, but in Python, constructors are just yet another method. So that method is called init. And here's an example of a method that takes in other parameters. So here we have self and then two other parameters. Often what you'll see, and this is kind of a pattern, is those parameters that we're taking in will immediately set them to self. And what this does is it's creating fields in the class. So unlike Java, you don't have to declare the fields in the class body. You just go ahead and set those fields. So we're just setting self.name equals, and that creates the field and sets it all in one line. Okay, we're going to write another method, the __str__. That's basically toString from Java. So here what we're going to do is we're going to construct a string with the fields. We access them through self. So that's another thing that trips people up in Python. you have to access things on self. So unlike Java, in Java, you can do this dot name, or you can just do name. It's up to you. But in Python, it doesn't do any kind of fancy this reference lookup. You have to reference the field on the thing that you're trying to reference it on. And that's also tied to the fact that we have to take in self as a parameter here. So that's, you can kind of see the correlation. So that will definitely trip you up. It trips me up every day. Well, every day I write Python, which is not every day. As much as I love Python, I don't write it every day. So, okay, we're creating a person object. And now if we call str on that person object, we get this string. And this is the string that we wrote up here. The interesting thing to note here is that calling str on that object in turn called object.__str. And this is a pattern you'll see in Python all the time. You'll have some function that's built in, and str is a built-in function. But what that function will do is just turn around and call some method that you define. So every object in Python has a underscore str method. And so this function, the str function, knows to call that method in order to get that string.
So if you just type like A into the terminal, will it output the same thing, or will it then like reference the objects?
Good question. So if you just, so what I'm showing here is actually a shell. This is the Python shell. And it's kind of a good way to just ad hoc test things. The question was, what happens if we just put A into the shell instead of str A? It calls a different method. It calls the repr method, R-E-P-R. So that's short for representation. So the idea is that when if you were to just say A here, what we're looking for is the representation of that object. But here we're explicitly casting it to a string by calling str on it. Yeah, good question. Other questions here?
If you did like underscore in, would it like return in or
Here, like we did another method, underscore in. No. So, no, this is not a cast. This is just a built-in method that all things have. So it doesn't work for any type. It just works specifically for strings. Other questions? Okay. So fields, we've already seen a couple fields. Those are fields. You reference them with the dot on self. And you can reference them anywhere. So here we reference the field inside the class with self, but you can reference it outside the class on an object by just putting a dot. And that field has state. So we have this object, we have some state, and then we call functions, and we can change that state. And so if you're new to object-oriented programming, this is kind of the whole paradigm. We wrap up a little bit of state and a little bit of functionality into a single package called an object, and then we can call the functionality and change the state. Methods, we've seen a couple. We saw init and string. Methods that start with the double underscore, they're referred to dunder. So I accidentally said it earlier, I was trying to avoid it, but you would say this is dunder string. This is dunder init. And yes, you can write a method called dunder Mifflin, but don't do that unless there's a good reason. And so there's several dunder methods. Dunder ek, comp, stir. And these map pretty directly to the methods that are inherited from objects in Java. And just like in Java, some of them map to syntax. So, for example, you can define the dunder add method in a class in Python, and then objects of that class will be addable. So strings are addable. If you add together two strings, you can concatenate them. Lists are addable in Python. So you take a list and add it to a list, concatenates the lists. That's implemented by implementing this add method. So that's another example of this kind of pattern. You implement the dunder method, and then you get some nice, pretty functionality. Some differences, Python methods don't have modifiers, so there's no public static void, which is nice. and everything is non-static, kind of. We've already seen one example of how you can take a non-static method that we've written that takes itself and call it statically. So static and non-static are kind of these, you kind of get both at the same time in Python, so there's no modifier for it. You'll also note that that means there's no private. So if you want something to be private, you just start the name with a single underscore. Yeah. Questions about any of this? I want one question.
There is a static method decorator, so what's the deal with that?
Sorry?
There is a static method decorator.
Good questions. Yeah. So yeah, I said that there's everything is non-static and there's no static. But if you've written some Python classes before, you might have encountered a decorator called static method. And what that is you can put in let's say I'm not going to write it down. But if you're right before defining the function, you could say @static method, and that's a static method decorator. What that does is it explicitly tells Python no need to pass self into this method. This method is not designed to be called on objects, so just forget everything about self. And so every time you call that method on an object, on the class, whatever, self won't be passed in. Yeah.
You say use underscore to mark private. Does that mean it's actually private or it's like convention?
Yeah, that's the question I was expecting. No, it's not actually private. You can still access it. It's which is pretty funny. Python is not secure. Like you can do just about anything, and we'll see that with metaprogramming. Other questions here? Those were two good questions. No? Okay. So on the previous slide we had init and new here. We already saw init is like the constructor, but then we've got this new thing that I said kind of maps to this. What is that? You might encounter new when you're Googling, so it's good to know what it is, and it will come back with a vengeance in the hardest lecture, metaclasses. Metaclasses are kind of like the quintessential confusing metaprogramming topic. And in that topic, we're going to need to know what new is. So I want to introduce new to you now, so that hopefully you can kind of just do. Init took in self like any other method. So it's a non-static method, and it takes in self, and then we populated it. We set fields on self. New is what makes self. So new is a static method. No, sorry, class method. What did I say here? Oh, this is wrong. It's not static, it's a class method. But essentially it doesn't take in self, because self hasn't been created yet. New is the method that's responsible for creating self. So how do you create an object in Python? The answer is, I don't know. That's what Python does for you when you call a constructor, right? We don't need to know about what Python is doing. Is it allocating memory here? Is it allocating some space on the heap? We don't want to know. So basically, usually when you're overriding new, what you're going to end up doing is calling the superclasses new, because only Python knows how to actually make an object. So that's a general pattern you'll see. Yeah, so I have an example here. If we have this class test and we define new, you'll note that instead of taking in self, we've taken this other thing, CLS. That's short for class. And what that is the class that we're writing itself. So this will evaluate to test. Not an instance of test, but the class test itself. And then we take in other parameters if we want. So, and just to see what's going on here, let's print out what this CLS thing is. Alright, and then like I said, since we don't actually know how to make objects, after all, we're just going to return super dunder new. Okay, and then we're also going to define a init just to see what happens here. And again, we're going to print out self. That way we can see the difference between CLS and self. Okay, so we make an object. What's the first thing that's going to be printed? New. Yeah. Yeah, the first thing that happens is when we create an object, new is called because new creates self. So init doesn't get called first. How could it? We don't have a self yet. So the first thing we have to do is we have to make a self. So the first thing that's going to be printed is this new thing. And we can see that CLS is equal to this, to the class itself. Not an instance of the class, but class test. And then init gets called, and then we get the test object at this address. Okay, so this is confusing, I'm sure. What's actually interesting here is that CLS here is a class. How can you pass a class in as a argument? You know, what does that even mean to pass a class into a function as an argument? A class itself. So a class is a template, right? It's not like variable. So this is kind of the first little hint at some serious metaprogramming that's going to go on. In Python, everything is an object. That includes classes themselves. Classes are objects. But don't try to wrap your head around that yet. We'll get there. So, questions about this? Mm-hmm.
So it prints out the memory address for where the object is allocated.
Yeah.
But
Why
it
did
doesn't
it
do
do it
that.
here?
I guess there's only going to be one of them, right?
I have no idea. I mean, so here's what we're really doing. Python is implicitly converting these things to strings. So it's calling the string method. So apparently, the string method for our test object, which we inherited from object, apparently that decided to print out the memory address. But here what we did was we called the string method on the class itself. And apparently that method is not implemented to print out the address. I don't know why. Maybe it's a security thing. I have no idea. Good question though. Other questions? Hopefully we're getting into some Python stuff that who's written a new method before? Oh, sweet. All right. Okay. So that was new. And like I said, everything in Python is an object, and that's really true. And we can test it. If you call the type function on a thing, it returns the type of that thing. And if you call .mro, we can see the inheritance hierarchy for that type. So we've got type of 1, we get an int. Now if we call type of 1.mro, I can prove to you that ints are objects in Python because, boom, we get a list, we see that the inheritance hierarchy for 1 goes int and then object. So ints inherit from object. This is different from Java, where ints are a primitive. And if you try to say, 1 dot, that's not going to work because they're primitives, you can't have dot access them. Strings are also objects. That's the empty list right there. So the type should be list, and the MRO, lists inherit from object. These are the same in Java. Java strings and lists are also objects. Here's a weird one though. What's going on here? First of all, does anybody know the type of this thing? Yeah, the type of print is function. And function also inherits from object. So this is another glimpse into some metaprogramming we're going to do here. The fact that a function can be an object is kind of inherently meta. Because functions we think of as code. A function is some procedure. And the fact that this procedure has been interpreted as an object in the language that we're writing in, that opens up some serious meta opportunities. Questions about this? Mm-hmm.
If you have multiple inheritance.
Multiple what?
What if you have multiple inheritance? What's that, right?
Oh, good question. We'll get there next week. Yeah, multiple inheritance we'll stick to next week. Other questions about this? This is really just kind of a glimpse.
What does MRO stand for?
Method resolution order. Yep. Other questions?
Do you have to call it on whatever type returns? You have to call MRO on whatever type returns.
Yeah, MRO is a method on type.
Okay.
And actually, this is another example of how classes are objects here. Because if you think about it, what is this a value to? Type of print? What is that? What is that object? It's a class. Yeah, it's a type. So we're actually subtly taking advantage of the fact that classes are objects in Python. Is that it's kind of swept under the carpet?
Can you call it on itself, MRO on itself?
MRO? No, because MRO. What do you mean by on itself?
Well, just add another .mro on the end of that.
.mro parentheses .mro? Like,
Yeah.
so we keep those parentheses.
Yeah.
And just say .mro.
Yeah.
That won't work.
It won't work. Okay.
No, because this evaluates to a list, the method resolution list. And list is not a class. List is a class, but a single list is not. So a single list does not have an MRO, but the class list does. Does that make sense? Okay, question?
We just tried doing
Does it work?
type.mro, but that says type isn't a function, so what's type?
Type is not a function, that's right.
The problem is that type needs an argument, so you can't just do type.
No, that's not the problem. There's a bigger problem. We'll get to it in meta classes. But it's true, type is not a function. But I don't want to say what it is. Because I have a whole slide set where the entire first half is a build up to that question. So you've really beat me there. I shouldn't have asked for questions on the slide. I should have moved on. Okay, let's see some examples. In Java, if we say string equals string, that's really bad. I don't know if you remember, but equals in Java strictly does memory address equality. So that's not really what we mean here if we're checking if two strings are equal. You would have to call the .equals method in Java. But in Python, like we saw on the methods slide, there's a dunder eq method, and the equals syntax knows to call that method. So we can use equals liberally here. And just to prove it, or I guess this doesn't really prove it. But, here we are explicitly calling the dunder equals method. This works for ints too, because ints are objects. So you probably have never seen it before, but you can call .equals, you can call a method on an int. It looks pretty weird. You have to wrap it in some parentheses, because otherwise it thinks that you're just writing a decimal. So you have to wrap it in parentheses, but you can call methods on ints because ints are objects. And so this will work. Okay. Let's see. Can anyone explain what a dict is? A dictionary? Mm-hmm.
It's like a super strong hash table. You can just add.
Yep, it's a hash table. Can someone who's taken 2150 explain to the people who have not taken 2150 what a hash table is? Because that's not. Yes, but.
It's a data structure that maps keys to values.
Yeah. Yeah, a hash table, and therefore a dictionary, maps keys to values. And so here, this is an empty dictionary, so there are no keys, there are no values. But we can assign a key and a value by doing square bracket assignment here. So here we've specified a key, A, and that A maps to 0. Okay? Here we've specified another key, 1, it maps to hello. One thing to note here is that because everything in Python is an object, these keys can be anything, because they just have to inherit from object. We didn't specify any kind of type here, we didn't say this is a dictionary mapping ints to etc. We just said it's dict, which means the keys can be anything, and since everything in Java is an object, I really mean literally anything. So we can have a string as a key, we can have an int as a key, we can also have the same for the values. The values can be 0 or hello, and this actually gets arbitrarily complicated. So here we have a tuple. This tuple is the key, and just like dictionaries, this tuple can contain things of any type, so this tuple contains an int and a string. We get that because ints and strings are both objects in Python. And then the value here is yet another dictionary. So here we've got a nested dictionary, a dictionary where the values are dictionaries. If you tried to type this into Java, I think you would break the world. Java cannot handle this because ints and strings are kind of fundamentally two different things. Strings are objects and ints are primitives. So now if we print out this dict, you see we've got some keys and some values. And one of the values is this other dictionary that maps to a function. We can map to functions because functions are objects. We already saw that. So this is kind of an example of the power that you get from having everything be an object. Anybody have a question about this?
You can also safely pass like classes and instances.
Mm-hmm. Classes and instances, yeah.
Don't the keys have to be immutable though?
Yeah, good question. That was, yeah. So here's I kind of lied. You can't use a dictionary as a key because dictionaries are mutable. Here we are mutating one right now. So dictionaries are definitely mutable, but you can't have your keys be mutable. So there are some limitations.
What do you do if you want to compare by address?
Good question. Is. So instead of saying equals equals, you say is. Yeah, good question. Other questions? Cool. Oh. No. Python is homogeneous. So since everything is an object, this is kind of weird. So how are these objects typed? Duck typing. So does anybody know what duck typing stands for? Why is it duck? Can anyone give us the reason? No one knows why it's called duck typing?
Sure, you know duct taping?
No, it does not come from duct taping because that's duct taping, not duct taping. Right? I'm right. Yeah.
Is it a quote like if it walks like a...
Yep. It's in reference to the quote, if it walks like a duck and it talks like a duck, swims like a duck, and I call that bird a duck. So that's what duck typing refers to. So what that means in Python is that we don't really care what the actual type of the thing is. We just care about what it can do. So if an object has a .walk method and a .swim method and a quack method, then that object can be a duck. We don't really care if it really is a duck. So that's duck typing. And it takes some getting used to. It allows things like this to happen. Say we have a method reverse. We take in this argument called string, and then we're going to make an output, and then for everything in that string, we're going to append that thing to the output, but at the beginning, so we're going to end up reversing the order. We return the output, and now if we print the reverse of hello, we get Olay. Print reverse 5, what's going to happen? It's going to break for sure. Where is it going to break though? Does anybody know?
Beginning of the for loop.
Beginning of the for loop, yep. Because, at the beginning of the for loop. Which is not what people sometimes expect because we call this variable string, right? The argument is called string, so it's clear to us that you should probably only pass strings into this reverse function. But Python doesn't know that. It's duck typed. So it's going to let you pass whatever you want in as string. And it's only going to break until whatever you passed in doesn't act like a string. So where that happens is in this for loop. You can't say for I in 5. What does it mean to iterate over 5? So the type error happens when the thing ceases to walk like a duck, not at any kind of function time or anything like that. Mm-hmm.
If we were to put quotation marks around 5 to like make it a string, what would happen?
Then it would work, because then you'd be passing in a string.
So it just becomes 5 again.
You would just get 5 back out, yeah. Okay, if we call print reverse on this list of strings, what's going to happen? Can anyone say what's going to be printed out?
CDBA.
Say it again.
CDBA.
CDBA? CDBA. Yep. CDBA. Does everybody see why? this worked, kind of. We passed in this list here, and this list, it turns out, actually was able to walk like a string in this scenario, because lists are iterable. So when we said for I in string, what we meant was for each character in the string. But what actually happened was we passed in a list. So we got for each element in that list, we appended that element to the string out. And appending the element of this list, which is a string, to a string concatenates. So it just so happened to kind of work. But what's weird here is that we reversed a list and got a string. Right? So it didn't really work. So this is an example of something to watch out for in Python. There's really no type safety at all. And you can kind of fake it with some assertions and warnings, but really be very careful that you're passing what you expect, what the function expects into that function. So be self-conscious. Get it? Self. All right. There's a wall of text here, so don't try to memorize this. So I said that in duck typing, all we care about is what the thing can do, right? What its methods actually are, not what the type is. And that means that every time we try to do something with an object, we're performing some kind of lookup, right? We have to check to see if this thing can walk. So how does that lookup happen? How do we know if an instance of an object can walk, has a walk method? Well, the mechanism is actually exactly the same as a dictionary lookup. So when you look up a thing in a dictionary, you're checking to see if that key is in the table. That's exactly what you're doing whenever you try to access any kind of field or method on an object. You're doing the exact same lookup. And it turns out that you can see that with a special field called dunder_dict. So here is type of list, type of this empty list. So that evaluates to the class list. And then we're calling we're accessing dunder_dict on that. And what did we get? We've got this dictionary, and some of these things should look familiar. We've got that dunder_add method, we've got a dunder_contains, we have append, and everything else. What are those things?
They're all the methods accessible by the type list.
Yeah, these are things that we could have called on that list. We could call .append on that list, .index. So what this means is that all of those methods are accessible in this dictionary. That's inherently meta, isn't it? Because we said earlier, functions are kind of like code. A function is a procedure, a method is a procedure. And here we have, in this data structure, representations of those procedures. So this is kind of meta. And this is yet another thing we'll see later on. This is called reflection. The ability to see the code that we're executing right now as data in that code. So just quick, just trying to give kind of glimpses of some of the things we'll get into. This is one of them. Questions about this? Okay. So here's what we did today. We talked about object-oriented Python, we did classes, talked about init and new, string, constructors, methods, fields. We don't have time to go into the group coding, so I'm just going to leave this up here. This is the homework. This is due next week. Sorry, in 2 weeks, because there's no class next week. This should be pretty straightforward, and in fact, what you have to do, there are examples of it in the repo. So you should be able to kind of piece together the examples and the slides to get the homework done. Everything is on the repo, but you can get to it through Lou's list. Like, comment, subscribe. No, in all seriousness, star that repo. Star the repo. All right, thanks.